Today we're talking about scientific notation. How many of you have done scientific notation before? Let me see if you... Okay, so Corey has. If you have big numbers, sometimes, and you're going to see we get some really big numbers in today's lessons. No, not yet, not yet. This is something you have to just switch over. Your calculator wouldn't do this for you anyway, I don't think. If you have a really big number, everybody focus. If you have a really big number, sometimes people don't want to write it out along this long way. For instance, I could have started with number 3. We'll do it next. If you had like 24 septillion, that's like 25 zeros after a number. And people get tired of writing all those zeros, plus, it's easy to forget one and just hard to kind of keep up with all of it. So there's a shorter way of writing things, and it's called scientific notation. And it's basically writing things and writing them as multiplied by a power of 10. For example, if I had this number 1.86, 186,000, what we would do, for example, here's what you do with the number. Let me write it down. I would want to put, where's my decimal right now on this thing? Where's a decimal when you don't see it? At the end, right? I could put 0.0 if I wanted to. So the decimal's at the end. What you do when you do scientific notation is you write one number between 0 and 9 to the left of the decimal. So for example, what I'm going to do is I'm going to stick my decimal point between that 1 and that 8. It doesn't look like that's where I'm pointing, but it would become 1.86. I don't need the zeros on the end because, I'll show you why in a minute. If I put the decimal place here, and I want to multiply by what would happen if I multiplied by 10 first? Wouldn't it move the decimal place over one position? Because like if you had 1.8 times 10, wouldn't that be 18? What would 1.8 times 100 do? Be 108. Yeah. If I took this number, let's say I had 1.8 times 10 to the second power. That's the same thing as 1.86 times 100, because what I can do is just write up here as the exponent how many zeros I have. Okay? I have 2 zeros, so that's times 10 to the second power. Isn't 10 squared 100, right? 10 times 10 is 100. So what I can do, that would tell me to move them over 2 places, and you would be right, I get 186. I heard Rachel say that, and probably some of the others of you too. So what if I had 1.86 times 10 to the third? That'd be like saying 1.86 times 1,000. What would that do? Yeah, it would be 1,860. When you multiply by a power of 10, the exponent ends up telling you how many places to the right to move your decimal place if it's a positive exponent. And we have a positive exponent here. So if I wanted to rewrite 186,000 as 1.86 times 10 to something, let me pick a different color here. So let's look at this problem here. This is actually problem solving number 1. If you look at I started with the word problems here just because I think it makes more sense to understand why you might want to do something like this. If I write this as 1.86, and I want to make sure my number is equal to the number I started with, all I do is I count how many places would I move this decimal from, I just moved it to between the 1 and the 8. I'm going to count how many spaces it would take to get it back to where it really goes. So if I put it right here, I could count 1, 2, 3, 4. Oh, I have to jump over 5 spaces to get it back to where it really goes, don't I? So this exponent tells me how many place values to move the decimal point. Luke?
No money.
Oh, you're stretching?
No,
oh.
I had it.
Are you sure?
Yeah.
Okay. So we notice there's one digit to the left of the decimal point, and you always do that. You don't put, it has to be 1 through 9, though. You don't put 0 out there. That's not considered proper scientific form. Let's look at some more. We're going to do the odds in class today, so we'll start with the problem solving because I think it makes it make more sense. 3 says so 24 septillion is written as 2.4 times 10 to the 25th using scientific notation. Write in expanded form. expanded form would be the way we normally see things, okay? It's like just writing it out the long way. Scientific notation is when we compress it. Do you see now why we might want to use scientific notation if we got something that's got this many zeros after it? So if I write this, here's what I can do. The decimal place is here, but this is telling me move the decimal point 25 to the right. And what I'll do is for every space that I move, if there's not a number there, I'll fill in with a 0. So let's get, okay, here we go. Let me get a different color just so we can. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I almost ran out of room on the iPad. Every one of those little bumps I make, I'm going to fill in with a 0. Okay, does that make sense? So do you see why people like scientific notation? Like if you were a scientist and you were working on traveling to Mars or something, you don't want to write out that miles all in longhand all the time. It would get really old. So that's why people use stuff like this. So what I'm going to do is going to come in here now, and I'm going to fill in all those little bumps I made. Those are an easy way to kind of make sure you get the right amount of zeros. What do you think I'm going to do once I get all these zeros filled in? Yeah, I put commas to help me read it, because this is going to be really hard to read, isn't it? And again, this is septillion. Goodness. Okay, so 1, 2, 3, comma, 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 1, 2, 3, comma. That's 24 septillion. My decimal place is now down here. So do you see why people might not want to have to do that? Wouldn't it be hard to keep up with that many zeros and get it right every time you needed to write a number down? And the thing about it is once you learn how to write numbers like this, if you were messing with those big numbers all the time, and by the way, we rarely do in high school, but if we can do this, then we can actually multiply and divide these numbers pretty easily. So there's a reason, once you get them in this form, you can actually work with them, and you use your rules of exponents actually to work with these is what you end up doing. So it's hard to keep up with those jumps. That's why I make those little U-shaped things, just so you know, fill a 0 in here, and that's what most teachers do too. Okay, so number 1, we have 84 million. And they say, if I write that in scientific notation, it's going to be 8.4 times 10 to what power? And they just call the power n. They just put a letter there so that you can go fill it in down here in the blank. So normally we would just put the number up there. This is just them giving you a little, practice at this. So if I'm going to move my decimal point right here to write it in scientific notation, that's not the same number. 8.4 is not the same number as I started with. To get it to be the same number, we got to count how many spaces we need to jump that decimal point over. So let's count together. 1, 2, 3, 4, 5, 6, 7. So the exponent here would be 7, okay? So it's just they wrote it a little weird in the book, but that's all they want you to do there. Let's look at 3. So 3 is 7 million. So they say you're going to write it as 7 instead of putting 0.0 when you got, when you usually got zeros after it, you can just write the whole number like this. 7 times 10 to the n power. So what would my exponent be here? 6. Let's see, okay? We would put it here because we want one number to the left, so let's count. You're right. 1, 2, 3, 4, 5, 6. So it will be 7 times 10 to the 6th power. So what you want to replace that n with is a 6. Okay, 87,900. If you've got a lot of, different numbers up here, remember you only want one number to the left of the decimal, so you would write 8.79. You basically chop the zeros off the end when you write this part of the number. Now, if I moved the decimal place right here, that's not equal to what I started with. So I need to move it over by how many decimal places? 1, 2, 3, 4. So it would be 8.79 times 10 to the 4th. So all they're asking you to do is just tell them what the exponent should be. And it looks a little strange, but it's not that big of a deal. On here, let me do 6. So I'm going to do number 10 because it's a little like that too. So let's look at 6 and 10. They're evens that you have to do, but it would help for you to see one of these. I don't. On 6, they say, okay, you're supposed to write it 6.281 because you just want one number over here to the left. Okay, but if I have moved that decimal point to here, how many do I need to move it to the right to get it back where it started?
1.
Just 1. So it's times 10 to the 1, n would be 1. Let's look at number 10 down there on the evens. I know this is when you were assigned, but for number 10, 387.65, I'm going to write that. What number will I write out front? What will this part of my number be down here?
3.877.
Yeah, I'm going to write all those digits because there's not zeros on the end. And so that means that I moved the decimal point right here, didn't I? But that's not where it started. Where did it start? How many digits over? 2. So it would be times 10 to the 2nd power.